Okay, so when you go for these digital modulation techniques, what are the topics you will be studying? These there are the topics which are covering this particular module are the introduction, then binary phase shift keying, quadrature phase shift keying, and then QPSK, BPSK, PSK, FSK, probability of error, and then transmitter, receiver, coherent receiver, non-coherent receiver, and then for the both the PSK, FSK, and the uh, what is that state diagrams you will be learning here in this particular thing, how to construct the binary or QPSK or PSK or orthogonal phase shift key modulated techniques, state diagrams, how to construct all these things you will be learning in this. But before we go for these QPSK or the PSK in detail, let us understand what is the basic idea we should have before we start understanding these PSKs in detail. Okay, so let us go for the introduction. So when you go for this digital modulation techniques, first let us understand the digital data transmission. When you go for this digital data transmission, there are two different types of data transmissions we can do. Able to see the right up, right, students?
Yes, ma'am.
Yeah, digital data transmissions are of two type. So till now, what we used to discuss is analog communication and digital communication. In analog, continuous signal we used to transmit, whereas in digital we used to convert this analog signal into a digital signal, and thereby we used to transmit. But again, if you go for digital data transmission, there are two types of data transmissions you can see. One is baseband data transmission, baseband data transmission, and the other one is passband data transmission. Okay, so what this whatever baseband transmission, we'll say that it is through the wired communication. Passband, it is through the free space communication we will be transmitting the data. So what are the advantages and the disadvantages? Let us see with the baseband data transmission. When you go for this baseband transmission, this data is transmitted over a channel without any modulation. Without any modulation. Any modulation, we will be transmitting data. Data is transmitted over channel. First difference you should understand. Okay. Next, what is next? A baseband signals have frequency components and power at low frequencies. So this baseband data transmission will have frequency and power components at low frequency. Whatever the information that will be transmitted in the baseband, it is of low frequency component, low frequency information, and its power also it will be very less. Frequency and power components at low values, not low frequencies, at low values. Both it will be applicable. Okay. This whenever there is an low frequency we are using, where we can transmit and how long we can transmit this type of baseband signal, it is suitable for shorter distance or short range communication. Okay, this is the another point you have to remember. Then how do we transmit? Because this is purely based on word communication, and it is suitable for only a short range of distance. Channel can be, because channels we need to choose whenever we go for word communication. Channel is your fiber optic cable, that is OFC cable, or sometimes you may go for pair of bars, or sometimes you may go for coaxial cables also. Fine. This is what the actual channel baseband data transmission, another important property. And what type of data with the baseband? Can you tell me if anyone has an idea of what type of signals can we transmit over the baseband transmission technique? So examples are, what are the examples? Low frequency components are what? Voice, that is 0 to 4 kilohertz frequency range signals, and your TV signals which are in the range of 0 to 6 megahertz. These signals can be transmitted over the baseband data transmission, because remotes, when we are using for a TV remote, it will be very shorter distance. For all those short distances, direct signal can be, information can be sent without any modulation. Then these are the examples for your baseband signal. And whenever the signal you are transmitting, signal transmission, that is baseband signal transmission over the channel, how the formats used are, because whatever the signal in digital communication we'll be using, that without modulation we are transmitting, but there is a syntax or the format we are following, that is, 1 minute.
Ma'am, not audible.
Yeah. Now if you go for this signal transmission, baseband signals or the channel transmission, when you start, it can be pulse analog communication, pulse like you can transmit, or 1 minute man, there is an important call. Pulse analog communication and pulse digital communication. So these are the two different techniques you can make use. Okay, what are these pulse analog communication techniques? Hello. Pulse amplitude modulation.
Ma'am,
Yeah, ma.
could you increase the font size, ma'am?
Why it is not visible?
Ma'am, not clear.
No, ma'am. Hello. Ah, ma. Visible? Okay. So pulse digital modulation. In this pulse analog communication, we can go for pulse amplitude modulation, pulse width modulation, and then pulse position modulation. So these are the three different modulations we can make use in the baseband data transmission. Means pulse amplitude modulation means amplitudes of the pulses you are going to vary. Pulse width modulation, these are all the modulation techniques. In fact, you have practiced in your practicals, that is in fourth semester analog communication lab. So these are the modulation techniques. Those are all coming under baseband data transmissions. If you go for, okay, now onwards, I'll increase the font size. Pulse digital modulation, if you are considering, this pulse digital modulation consists of different techniques. That is, one is pulse code modulation. Have you heard of this modulation techniques? Yes, students? PCM.
Not the PCM.
Yeah,
We have,
PCM.
ma'am.
You had in syllabus, at least somewhere you have studied.
Yes, ma'am, in PCS we had.
Yes.
Yeah, differential pulse code modulation, and then delta modulation, then another type is adaptive delta modulation. So PCM is one, DPCM is another one, then DM is another one, ADM. I think all these modulation techniques you are very well know what exactly the difference between the first modulation and the in pulse amplitude, pulse position modulation. I think pulse position modulation you have done using 555 timer, right? Pulse width modulation and pulse position, 555 timer. Do you remember? Students.
In theory, we have studied, ma'am.
In theory.
Not practically. Maybe
No,
in
ma'am.
your lab sessions you may not have. But earlier students used to study this PWM pulse width modulation using 565 oscillator, then pulse position using 5555 timer. So these are the two different ICs we used to use, and we used to make students to learn with pulse position, but all these pulse position are pulse width, ppm, pcm, dpcm, dm, adaptive delta modulation, all comes under baseband data transmission, which can be used for the signals which are voice signals or TV remote signals which are of low frequency signals. Then what exactly this baseband pass band signals are? So let me take that second one as your pass band signals. Now can you tell me what exactly the pass band data transmission is? Counterpart of this baseband. So now here we are going to transmit these signals with modulation or without modulation. My first question. The data transmissions. Yeah, please speak out. Yeah, first difference, that is counterpart of it. There no modulation, whereas here the digital data transmitted with a high carrier frequency, that is the carrier frequency, we will be adding and modulating the signal and we are going to transmit. Then what are the techniques? Because frequency and power components are low in case of baseband signal, then here whenever we are going for the modulation, these techniques, whatever the techniques we are going to make use, the modulation techniques suitable for techniques suitable to cover long distance communications. Okay, and then so the types of modulation signals we'll be using for a types of passband signals. We come across passband signals we'll come across are as follows. Passband signals are of two different signals we can make use for data transmission, which are those. It is the first one, if you look at here, it is the binary signaling. Okay, this one way it is binary signaling you can make use. The second type is M-array signaling. In binary signaling, there are three methods we can make use. One is ASK, the second one is FSK, and the third one is the PSK. Whereas if you go for M-array signaling, I'll tell you what exactly the difference between an M-array when I start with your actual modulation techniques. QPSK, then 8 PSK, 16 PSK are the different M-array signaling schemes we have. We'll be making use for the data transmissions. And this is the second. Data transmission will be with a modulated signal of high carrier. Modulation techniques, whatever we'll be using, will support for long distance, and there can be an M-array signaling, or you may go for binary signaling for the modulation techniques. The next difference between the passband and the baseband is that channel is free space. Channel is free space here in the passband signals. Sorry, free space. Okay, these are the main differences 1 minute. The next difference is the channel is free space. Okay. Now, what are the advantages of passband data transmission? Okay, the first one, simpler and cheaper. Because advances in IC technology, because most of the whatever we'll go for the actual circuits designed for the digital communication is able to fabricate on an IC, and we are able to we are able to fabricate an integrated chip. Hence, when you go for an passband transmission, we feel that it is simpler communication, simpler and cheaper communications we can build in. The second one, it is in digital communication, in using passband signaling, through passband technique, the speech, video, and other data may be transmitted over the common channel using multiplexing. Means whatever the type of signal you are going to choose, these type of signals can be speech or video or audio or any other signals, data signals also you can choose, and you can transmit all these signals over the common channel using the multiplexing. You have TDM and FDM. Using this TDM technique, most of the times we'll go for time division multiplexing. So in using such multiplexing techniques, we'll be transmitting the passband signals of multiple different types. Here in a passband signal, when you are transmitting over a free space, data encryption is possible. So you can encrypt the data. So what do you mean by encryption of data? Yeah, what do you mean by encryption of data? Yes, someone who can speak.
Hiding the original content.
Yeah, hiding means data privacy can be maintained. So this data privacy, what exactly means? It is only the permitted receivers are allowed to detect the data, because once the data has been encrypted, here there will be some additional keys, means additional bits like keys we are going to add it at the transmitter side. The same key will be forwarded to the receiving end side. Only with that key, if the data the receiver, authenticated receiver starts receiving with that same key which has been transmitted at the transmitter, the receiver can detect. Otherwise, a hacker cannot receive the data. That is what the data encryption. This data encryption is possible with passband signal transmission. And another important advantage of this passband is that low noise interference. Interference occurs because the data transmission is of digital in nature. Okay. The next one advantage is that error detection, because many techniques you might have learned in your information theory and coding to error detection of error detections and error corrections. So therefore, error detection and is possible with passband signals. Hence, it is an added advantage to go for passband transmissions. So parallelly, this passband transmission has disadvantage too. The first disadvantage, due to whenever we go for an analog signal to transmit over a channel converting into digital, so we have to subject the signal into the process of analog to digital conversion. Analog to digital conversion always converts a simpler analog signal having a low data rate into an higher data rate after converting into a digital data. So that is one disadvantage we can see with respect to this digital signal or passband signaling. So analog, due to analog to digital conversion, data rate becomes very high. Whenever big data rate is becoming very high, what is the another disadvantage you will face? Data you need to transmit over the channel. What is the problem that as a designer you? Yes, one of you can answer. The one disadvantage is bandwidth. Requirement will be more. And whenever this passband signaling transmission, when you chose synchronization is
Ma'am, voice is break.
yeah. So these are the two disadvantages if you take this passband signaling. One is that the digital to analog to digital conversion, when you the data which is going to be generated from a digital conversion signal will be very high. When you want to transmit this high data over the channel bandwidth requirement also it becomes more and more. And when these digital modulation techniques like you digital modulation technique, when you make use the synchronization, coherent detection should be used. So therefore, and also because of the encryptions, so whenever we go for the coherent detection, synchronization between the transmitter and the receiver, it is very much essential. So these are the two disadvantages, but over many advantages, these two disadvantages will be always subsidized, and passband signal transmission will be taken care in most of the communications. So what are the benefits? Benefits of passband. Can you tell me? Passband data transmissions, at least anyone. Now I have discussed passband as well as the baseband signals in detail. What are exactly the baseband, passband, and what are the advantages, disadvantages? Can you tell me the passband data transmission? One advantage, long distance communication is possible. Long distance transmission. Second one, multiplexing techniques can be used for bandwidth conversion. So TDM, what this TDM will do? TDM will multiplex many signals over a single channel. So therefore, multiplexing techniques can be used for bandwidth conversion. Fine. These are the various advantages, and coming to other advantages, the third advantage is that you cannot see crosstalks. Problems such as ISI, which is nothing but crosstalk. Crosstalk is absent in case of this passband signaling. The next advantage is that passband transmission can take place over wireless channels. Passband transmission, yeah, that is an advantage only, right? Passband transmission can take place on wireless channels. So you will be avoiding the manpower, cost of material, everything when you go for wireless channels. Only the competitive authority has to allocate the frequency. That is an advantage. Okay. The next one is minimum circuit complexity. Why minimum circuit complexity? Why minimum circuit complexity, students? Because we are going for most of the designs with ICs, so therefore minimum circuit complexity you can see. Availability of, another advantage is that availability of large number of modulation techniques. Okay. Okay, now these are the different types of modulation techniques you have in case of the digital communication. And when you go for the definition of modulation, because before I start with PSK, I wanted to make you clear where what type of modulation technique we are going to make use, whether it is a passband or the baseband. Definition of modulation. Can anyone define the definition for modulation? Please, general modulation definition. Yeah, it is a process of students. I am asking you only.
The signal is modulated with a carrier signal to transmit the signal over a long distance.
Okay. Any other definition from other students?
Ma'am, where the frequency and amplitude of a carrier signal changes.
Yeah, very good. Okay. So a carrier signal will be added to the information signal, but how, that is very important. Please, when you are giving the definitions, please take care what exactly the characteristics of the carrier you are going to change. Okay, the characteristic, it is a process by which some characteristics of, basically we are changing the characteristics of a carrier wave. Carrier wave, for the reference, with reference to what? Carrier wave. Some characteristics of carrier wave is varied in accordance with what? What is the signal as the reference? Which is
Message
the
signal, ma'am.
yeah, message signal or the modulating signal. Modulating signal is your message signal. Carrier wave is your carrier. Modulated signal is modulating signal plus the carrier signal. When you add it through some process, then that is termed to be a modulated signal. Okay, so this is the modulating signal is also termed as the message signal. Now, different types of modulations are available. One is the amplitude shift keying. Amplitude shift keying, ASK. Second one is FSK, that is frequency shift keying. FSK, and then the third one, it is the phase shift keying. Okay, what exactly the difference here? Whatever it is, you are going to define the modulation. It is defined with respect to the carrier wave. So therefore, you consider a carrier. I'll tell you a simple way how to remember this modulation. We consider carrier wave. How do you define a carrier? AC into cos omega ct plus or minus phi. Is it not the correct, is it not the equation that we are going to choose for the carrier? In this, when AC, please remember the AC of this carrier without changing this cos omega ct plus or minus pi, when we are using, 1 minute, man. Let me connect the charger. Yeah, whenever we are changing the amplitude of the carrier, it is termed to be the ASK. Amplitude of the carrier, that is AC term. When it is varied in accordance with the message signal, it is ASK. When you take, this is the first method. The second method, AC cos omega CT plus or minus phi. When omega is nothing but what? 2 pi FCT. When this term alone it is changed, that is FC, it is termed to be the FSK. The third technique, AC cos omega CT plus or minus phi. What is this phi? It is the phase angle. When phi alone it is changed, what is this? Changes as per message signal. What is this term to be? Yes, what is this?
PSK, ma'am.
Yes.
Phase shift keying. So this is simplest way to remember. When you change AC, it is amplitude shift keying of the carrier as in accordance. Suppose your message signal AC has the message signal has 5 sine 2 pi FMT. So this amplitude will be, and it is assigned to AC, then that is termed to be an ASK. If the frequency, message signals frequency is, carrier's frequency is changed in as per the signal, more message signal. So message signal, if you are taking 00011011 as the symbols during that transmission, for 00 some frequency, for 01 one more frequency, for 010 one more frequency, for 11 one more frequency. When you assign such modulations are termed to be the frequency shift keying. And when you make for 00 with an phase angle of 0, for 01 pi by 4, and for 10, because when you go for by bits, dual bits to combine to form and symbols, 4 symbols are possible: 00, 01, 10, 11. When this with 0 degrees, this with pi by 4, this with 3 pi by 4, and this with pi by 2, then such phase angles, when you are changing, it is directly equal to PSK. So in ASK, what will be? 1 volt you may assign, 2 volts you may assign, 3 volts you may assign, 4 volts you may assign. So then it is termed to be the phase shift, amplitude shift key. When you go for frequency shift keying, F1, F2, F3, F4, like this, you will be changing the properties of the carrier as per the modulation message signal. So in such cases, it is termed to be the frequency or phase or the amplitude shift keying. Now, before we go for any of the modulation techniques to discuss in detail, choice of modulation techniques we have to know, because where many modulation techniques are available, choice of modulation techniques based on what characteristics? Following parameters. Can anyone tell me what are the parameters which may be chosen as the reference for the modulation technique, whether to go for ASK or to go for PSK or to go for FSK? Yeah, what are the parameters? So whenever any modulation technique we are using, because a digital communication has to support for long distance with high data rates, maximum data rate, which particular technique that is able to give, that you have to, as one parameter you have to consider. And then minimum probability of error per symbol. Then the third parameter, minimum transmitted power, because transmission power also very important, because most of the time we go for wireless communication, devices should drive for long durability. So therefore minimum transmission power. Then the fourth one, minimum channel bandwidth. Whenever it is getting transmitted over the channel, it has to make use minimum channel bandwidth. Then maximum resistance to interference signals, means zero ISI it should give. Zero ISI it should give means maximum resistance. And the next parameter that we have to choose is that minimum circuit complexity. Okay, these are the important parameters we have to consider when we are choosing any modulation techniques.